What could have surprised us 50 or even 20 years ago? The idea of colonizing Mars, growing artificial organs, unmanned vehicles. Right now, we will share news that will shock even today's inhabitants of Earth, and a few decades ago, it would have been taken as a quote from a science fiction novel. So most likely, we are living inside a black hole, and in this enormous bubble, Dyson spheres built by highly advanced civilizations are neighboring us. How do you like that twist, Cubble? Subscribe. Black holes are frightening, almost unexplored objects. What we know about them is like fragmented scraps from which we try to piece together a monumental canvas. Basically, all that is known about black holes is the fact of their deadly danger. Mysterious dark funnels are extremely massive bodies that have literally collapsed into the fabric of space, bending it significantly. The second cosmic velocity, or escape velocity, in the case of black holes, is higher than the speed at which light travels. That means even photons of light are unable to escape the event horizon, the imaginary line after crossing which there is no way back. But how did Earth end up in a black hole? If we assume the theory is correct, as the physicists from the University of Rhode Island did, the absurdity of such a scenario immediately becomes apparent. Black holes are so massive that they can distort and deform enormous stars, gradually pulling them into their deadly embrace. Again, we must not forget about the process of spaghettification, which inevitably occurs to objects consumed by the insatiable vortex. But if Earth were to survive even this ordeal, it would end up in the region of a hard singularity. Under such conditions, our planet would turn into a tiny object of extremely high density, on the surface of which life could not develop even theoretically. Therefore, the theory that Earth was once boarded by a black hole should not be taken into account. Common sense tells us to rule it out. Are there any alternative hypotheses? Yes, and one of them suggests that our planet originally formed inside a black monster. Get ready. Now we will try to shake the very foundation of astrophysical concepts on which astronomy is based. The hypothesis was put forward by physicists from the aforementioned university, and it goes as follows. The Big Bang is a detonated singularity of a black hole, meaning the funnel kept compressing until it exploded, giving birth to the universe we live in now. But the problem is that the parent universe of this black hole must be of even more incredible size. After all, just like ours, it contains billions of such objects. The theory is called Schwarzschild cosmology, by analogy with the Schwarzschild radius. According to it, any object can be compressed so much that it turns into a black hole. For example, for Earth, such a radius is similar to the size of a matchbox. So, it turns out that universes, like nesting cups for children, can exist inside each other. In that case, is it possible to get from one to another? That's unlikely because of the reason we mentioned earlier. A black hole, even if it's someone else's universe, can't be left by anything in this world, except for Hawking radiation. But that's another story. Naturally, at the current stage of humanity's technological development, we are unable to prove this theory, but theoretically, the scenario is quite possible. At the very least, because our universe, just like a black hole, has an event horizon beyond which, even with modern telescopes like James Webb, we are unable to look. As an alternative to Schwarzschild cosmology, there is the bubble universe model. Its proponents believe that at some point, as a result of the chaotic separation of collapsing matter inside a black hole, our universe could have also emerged. That is, it did not reach singularity, but instead began to expand from a kind of protuberance that bounced inside the cavity. Another piece of evidence that we live inside a black hole is the recently discovered rotation of galaxies in the early universe. This phenomenon was discovered by the James Webb Telescope. The galaxies in question appeared just 300 million years after the Big Bang, and it turned out that they are rotating in the same direction. This prompted scientists to take a closer look at the phenomenon and, as a result, publish detailed studies in the monthly notices of the Royal Astronomical Society. The astronomers did not expect to discover anything sensational. Monitoring the universe with an innovative telescope was aimed at studying the process of galaxy formation and the growth of supermassive black holes. But during the observations, the scientific community encountered a number of surprises. One of them was the clearly visible rotation of galaxies, and all in the same direction. Previously, it was believed that there should not be a clear direction common to all star clusters. However, it turned out that 40 of the studied galaxies rotate counterclockwise, while 60 rotate clockwise. A total of about 270 galaxies were studied, which is enough to draw certain conclusions about why this phenomenon is observed. One of the reasons is the possibility that our planet is inside a black hole. However, such conclusions seriously undermine existing theories about the cosmos, revealing clear gaps in our knowledge. Another explanation for this phenomenon could be the Doppler effect. In that case, it would be necessary to recalibrate the measurement of distances in the universe to avoid further inaccuracies. In any case, the best scientific minds are working to explain the paradox. Research continues. But what if the first option is correct? The surroundings of galaxies suggest that our home is a black hole. Are there any ways, even indirect ones, to find out the size of the global universe in which this funnel is located? Let's assume that Earth is inside a cocoon the size of the solar system. By the way, a mathematician from the University of Massachusetts has already suggested this. So, what was the result? If this statement were true, people on Earth would surely have noticed the peculiarities of such a limited space. For example, we would visually observe the rotation of a black hole everywhere, and there would be effects of time and matter distortion. You wouldn't even need to leave Earth for that. During a trip, say, from Berlin to London, passengers would regularly experience spaghettification. Such obvious effects are hard to miss. So, how big should the cocoon that encloses the Earth be? Most likely just the size of our universe. It's frightening to imagine the scale of the parent conglomerate. Even more terrifying is how the black hole around us sounds. It's amazing how we live inside this hell and don't even realize it. By the way, the theory that Earth is located inside a black hole helps solve the problem of information disappearing into the funnel. This paradox has puzzled astrophysicists for many years. If the theory that our universe is located inside a black hole is correct, then it turns out that information doesn't disappear anywhere. It's just stored somewhere else. It's like transferring yottabytes of data from a flash drive to a hard disk. Are there any downsides to these assumptions? Absolutely, and the first one is the lack of observable evidence. Perhaps you could suggest how to test the theory experimentally. Unfortunately, scientists are not able to handle this yet due to the unimaginable scale of the field. Is it difficult to accept we've been living in a black hole all along? It's hard for us, especially if you imagine how many objects besides our humble planet are in this space. These star systems, galaxy clusters, and anomalies with nebulae. Finally, the Great Attractor and the Hercules Corona Borealis Great Wall, which is up to 10 billion light years across. But here's what's interesting. Could there be any man-made structures among these megastructures? For example, a Dyson sphere. Let's start with the basics. A Dyson sphere is an astroengineering structure created to harvest energy or provide additional living space for colonists. Of course, at the moment this is a hypothetical project, since the structure would have to be built around a star or a black hole. And it's not even about the fact that, according to the Kardashev scale, only a Type 2 civilization would be capable of building such a technological giant. We don't even reach the first type. There's another problem here. Which planet in the solar system stands out among its neighbors? Obviously, it's Saturn, because of the rings encircling its impressive waste. You might ask, what does our gas giant have to do with Dyson spheres? The connection is direct. Previously, when studying Saturn, there were theories that the planet's ring was a solid, continuous object. But Christian Huygens, the Dutch mathematician and astronomer, he was the first to suggest that the rings are made up of tiny particles. Otherwise, Saturn's gravity would have simply torn them apart. Don't you see the connection between the Dyson sphere and Saturn's rings? Undoubtedly, such a megastructure would eventually meet the same fate as a solid ring: inevitable destruction. There were options considered for an extremely powerful engine to constantly push the sphere or ring back into place, but those are just details. However, strictly speaking, the structure doesn't necessarily have to look like a sphere or a ring. It could be a swarm. Remember the movie Geostorm, but is there anything like that in our universe? It turns out candidates have already been found. In May 2024, a study called Project Hephaestus was published, in which scientists revealed some astonishing results. Physicists from Italy and Sweden studied data from 3 telescopes, analyzing about 5 million stars. Among the multitude of celestial bodies, astrophysicists discovered objects with excess infrared radiation. This very radiation is considered a sign of the presence of some kind of megastructure around a star or a group of stars. Notably, scientists from these countries worked independently, but the results of their research coincided. This inspires even greater confidence in the information presented. So, what did the astrophysicists discover? At a distance of 900 light years from Earth, there are red dwarfs that should be much dimmer than the sun, but they shine 60 times brighter. Why? According to scientists, the excess infrared radiation comes from an unknown object that blocks the star by about 15. This is a fairly hot megastructure, whose temperature is estimated to be around plus 400 degrees Celsius. It might not be a sphere, but a Dyson swarm, which doesn't make the discovery any less significant. Could such anomalies be caused by natural processes? Of course they could. A similar effect is created by a hot protoplanetary disk. But here's the inconsistency. The red dwarfs we're talking about are quite old, so it's unlikely that young planets are still actively forming around them. It could also be a natural phenomenon that we don't know about yet, or a galaxy that just happened to be in the line of sight by coincidence. We think it's possible. Right now, hopes are pinned on the James Webb Telescope. It is expected to conduct additional spectroscopic studies in the future and determine exactly what is the source of the infrared radiation, whether it's artificial or natural material, in order to prove or disprove the mentioned theories. Do you know what it is? We are absolutely certain that despite predictions about the disappearance of many professions, just like lamplighters, cab drivers, elevator operators, and telephone operators have faded into history, astronomers will definitely remain on Earth. After all, they will have enough work for several centuries to come. How much do we know about space? To us, people of the 21st century, it seems like we know a lot. Not a single corner of the universe can escape our attention, and we think we already understand how the world works. But is that really the case? Sometimes the universe gives us a wake-up call, presenting us with new mysteries. That's exactly what happened in the fall of the crazy year that just passed. Scientists discovered a planet whose very existence calls into question our usual understanding of the evolution and life of cosmic objects. As you know, the starry sky never goes unnoticed for a second by people on Earth, armed with satellites and telescopes. One of them is Transiting Exoplanet Survey Satellite, a National Aeronautics and Space Administration satellite aimed at searching for exoplanets and planetary systems outside the solar system. The goals of this program, carried out by an international group of astronomers, are the most ambitious. First and foremost, it is the search for exoplanets similar to Earth, which in the future may become a potential home for humanity. The program has already discovered many types of planets that are unlike those found in our small solar system. But in September 2020, scientists saw something completely unique. And it's not just about an exoplanet, but an entire mini planetary system that, in principle, shouldn't even exist. So what is it like? When astronomers observe the transit with National Aeronautics and Space Administration's Transiting Exoplanet Survey Satellite in the constellation Draco, about 80 light-years away from us, something unusual caught their attention. It was a huge object located almost right next to a dim white dwarf, orbiting it at tremendous speed. To determine whether it was a star or a planet, scientists studied the object's infrared radiation using the Spitzer Space Telescope. The results shocked the scientists. Not only did the object turn out to be a giant planet, which was named White Dwarf 18,556b, but scientists also discovered that it was cold, not hot at all. What should you expect from a planet that has come so close to a star? The upper temperature limit of White Dwarf 1856 is only 17 degrees Celsius, which is comparable to the temperature on Earth. Just imagine, a planet almost pressed right up against a half-dead star has a cool, comfortable temperature for humans. Moreover, the size of White Dwarf 18,556b is comparable to that of Jupiter, and it is 7 times larger than its fading star. The White Dwarf itself is quite small. It's only 40% larger than Earth. To imagine what this pair looks like, just picture Earth orbiting around the Moon. Although in this case, the White Dwarf is even smaller compared to its planet. You have to admit it's an amazing sight, but that's not even the strangest part. White Dwarf 18,556b is so close to its star that a year there lasts only 34 Earth hours. That's more than 60 times faster than the time it takes Mercury to orbit the Sun. How can a planet be so close to a star and have such a low temperature? Why hasn't it been destroyed by radioactive radiation yet? That would be a fair question if we were talking about an ordinary star like our Sun. But with white dwarfs, the situation is completely different. So, what exactly are they? White dwarfs? This is one of the final evolutionary paths for those stars whose mass is not enough to become neutron stars. For this, a star needs to have a mass of at least 10 solar masses, but smaller stars have only one path ahead. In the process of constant thermonuclear nucleosynthesis reactions, which are the main source of energy for stars, sooner or later, there comes a stage when the star expands, turning into a red giant. Its temperature drops during this process, and as further fusion reactions occur, the red giant cools down even more. And at some point, the star sheds its outer shell, which consists of gas, losing about 80% of its mass, and leaves behind a plasma core with enormous mass and very strong gravity, which then becomes a white dwarf. It, in turn, also goes through its own path, gradually cooling down and losing brightness. Does this mean that white dwarfs are cool enough for planets to coexist peacefully at such a short distance? Are there really none near them at all? A year before the discovery of White Dwarf 18,556b, researchers, working with the European Southern Observatory Telescope, discovered a hot white dwarf surrounded by an accretion gas disk and a partially destroyed planet not far from the star. By analyzing the radiation from the dwarf, scientists discovered unusual elements in its spectrum, which literally formed a disk around the star. The conclusion was obvious and relentless. Particles of hydrogen, oxygen, and sulfur swirling around the white dwarf. This is the evaporation of a Neptune-like planet that is too close to its neighbor and is being destroyed by the gravity and powerful radioactive radiation. The white dwarf literally evaporates and destroys the planet, pulling particles in with its powerful gravitational field. And unfortunately, the same unenviable fate awaits the planets of the solar system in the very distant future. So white dwarf 18,556b is not the first planet orbiting a white dwarf. It's not unique, not at all. The planet we talked about earlier was almost destroyed by its star, but white dwarf 18,556b is doing just fine and isn't about to break apart or evaporate. This is the first planet of its kind discovered by scientists. It would seem obvious. A white dwarf destroying its companion is too hot, while its neighbor, white dwarf 18,556b, which scientists estimate to be at least 10 billion years old, is quite old and cold. And it cannot not only harm the giant planet, which despite its size is much lighter than it, but also cannot even heat it up enough. So what then is the contradiction and the mystery for scientists? The question is, how did white dwarf 18,556b manage to survive the transformation of a red giant into a white dwarf, which is always accompanied by a powerful explosion and a release of gas? Usually, when a star sheds its outer layers, the energy released is so powerful that all nearby objects are destroyed, and their debris can then be pulled in by the strong gravitational field of the exposed stellar core. White dwarf 18,556b somehow got very close to its white dwarf and managed to remain intact, said Andrew Vanderberg, Associate Professor of Astronomy at the University of Wisconsin-Madison. The process of forming white dwarfs destroys nearby planets, and anything that later comes too close is usually torn apart by the star's immense gravity. We still have many questions about how white dwarf 18,556b ended up in its current position and survived. But if white dwarf 18,556b managed to survive, does that mean Earth also has a chance not to be torn apart when our sun undergoes the same grim transformation many billions of years from now? Maybe it all depends on the mass of the planet. If Earth were the size of Jupiter, it could survive. Unfortunately, it's not. Unfortunately, the existence of white dwarf 18,556b doesn't prove that a planet can survive the explosion of a red giant, especially since, even if it somehow wasn't destroyed, white dwarf 18,556b would face the same fate as the planet we talked about earlier. It would be scorched and gradually destroyed. A young and hot white dwarf means only one thing. At the moment of the red giant's explosion, white dwarf 18,556b must have been at least 50 times farther from its current distance to the star, and only much later migrated toward the white dwarf. How did this happen? Obviously, despite its powerful gravity, the stellar core wouldn't have been able to pull such a distant and massive object toward itself. The hypotheses that scientists put forward on this matter are numerous and diverse. The most likely scenario is related to several other Jupiter-sized bodies close to the original orbit of white dwarf 18,556. B noted Julieta Becker, a research fellow of 51, Pegasi B in the field of planetology at Caltech, the California Institute of Technology in Pasadena. The gravitational influence of such large objects can easily provide the necessary instability to knock the planet inward. But at the moment, unfortunately, we still have more theories than data. So for now, we can only guess how white dwarf 556b ended up in its current position. Did it survive the explosion of the red giant? Manage to withstand the radiation of a young plasma star? Or did it take a very long and mysterious journey, eventually ending up in orbit around the white dwarf? Scientists plan to obtain new data regarding this mystery with the help of the future James Webb Space Telescope. For now, all we can do is wait for news and reflect on how little we still know about the structure of this world. In 1950, Ray Bradbury's novel The Martian Chronicles was published, but could the writer have imagined that its title would take on a completely non-fictional meaning? Only 70 years later, millions now follow Mars news. And today I have some hot news for you. Minus 90 degrees, straight from the Acidalian Martian Sea. So, as we already know, the Perseverance rover landed back on February 18, 2021. Another source of pride for scientists was the discovery of a real stone field. Of course, now Earthlings can already see a panoramic photo of Martian rocks. It's tough for the hard worker to operate in such conditions, but don't worry. The wheels of Perseverance are built for even harsher environments. They give the rover a bulldog-like grip on the rugged Martian landscape thanks to individual motors for each wheel, titanium spokes and tubes, and a total of 48 tread cleats. It easily handles rocks up to 40 centimeters high. And that's not all. Both the front and rear wheels are equipped with steering motors, which means the rover can turn 360 degrees, preventing it from getting stuck. I wish Traxxas would implement this technology. All this is so impressive that you have to admire the scientists and engineers behind the device. But why do these talented people lose so many nerve cells daily? It's because every gifted person worries about their creation. Every step, every fall is an emotional experience for them. I really hope that my channel is watched by those who are truly passionate about this topic and are interested in the mysteries, not only of their home planet, but of the entire universe. Do you believe in Vanga's words? Life will be found in space, and it will become clear how life appeared on Earth. After all, by exploring space, we learn more about ourselves and about our home called Earth. But let's get back to the hero of our report, the rover Perseverance, or more precisely to its protege, the drone Ingenuity. It was Ingenuity that made its creators quite nervous. The drone's first flight was supposed to take place on April 8, but then it was postponed to the 11th. But unfortunately, in general, everyone who follows the Martian Chronicles was informed by the press service of the American Space Agency, National Aeronautics and Space Administration, that the flight would not take place before April 14. So what happened? After all, just recently Perseverance sent an excellent selfie with the drone to Earth, but the problem was caused by a software malfunction. Unfortunately, the coverage of unsecured Wi-Fi on Mars still leaves much to be desired, and the update took a lot of time. I think we can forgive the specialists for such an error, since the thin Martian atmosphere is only 1% of Earth's atmosphere. Anyone could get confused in such conditions. Fortunately, the software has already been updated, and the direction of Ingenuity's movement is now known, just as expected. The little guy, weighing just 1.8 kilograms, has two powerful coaxial rotors measuring 1 meter 20 centimeters in diameter, spinning at 2,500 revolutions per minute. By the way, before the Perseverance rover landed on the surface of the red planet, another Mars rover called Curiosity celebrated a kind of anniversary. This old fellow, which is actually a fully autonomous chemical laboratory, arrived on Mars on August 6, 2012. During its mission, it has collected a real archive of Martian landscapes and still regularly sends Martian weather forecasts back to Earth. We hope that Perseverance will repeat the success of its colleague and work just as efficiently, although that's not guaranteed. Not so long ago, the internet exploded with images of the surface of the Red Rebel. Hundreds of thousands of people discussed the footage sent by the rover to its creators, where a rainbow is clearly visible. But is it possible for a rainbow to shimmer with its colors on Mars? Of course not. The National Aeronautics and Space Administration, explained the unusual photo from Mars. A rainbow appears when light is reflected from water droplets. But here, there isn't enough water for condensation, and it's also too cold for it to be liquid. This arc is a lens flare. But then how can we explain these mysterious traces on the Martian surface? I'm waiting for your suggestions in the comments. However, not so long ago, Perseverance delighted its creators with the success of a unique experiment, a breakthrough for all of humanity. As you know, the main task of the rover is to collect Martian soil and search for traces of biological life. But the tireless worker managed to extract the first oxygen from the atmosphere of the red planet. According to the National Aeronautics and Space Administration, such an incredible success became possible thanks to a very compact device, the Mars Oxygen In Situ Resource Utilization Experiment, or Mars Oxygen In Situ Resource Utilization Experiment for short. With its help, 5.4 grams of oxygen were extracted, enough to support an astronaut for about 10 minutes. At the same time, the device took only an hour to do this, although it spent a full 2 hours preparing for the experiment. But does it really matter when science fiction becomes reality? Maybe it's not for nothing that the famous songwriter Yevgeny Dolmatovsky promised us that apple trees would bloom on Mars. Of course, this is just the first step, but a very promising one. Perhaps the time when people will be able to enjoy blue Martian sunsets and sunrises is not far off. Yes, because of the scattered atmosphere, sunrises and sunsets on this planet are very different from Earth's. By the way, oxygen on Mars is needed not only for astronauts to breathe, but also for rocket fuel, so it looks like a one-way trip to the red planet is off the table. After all, delivering 50 tons of oxygen and 14 tons of rocket fuel for a round trip for 4 astronauts would be an impossible task for the specialists. Now, producing fuel right on site doesn't seem so fantastic anymore, thanks to the very promising and innovative Mars Oxygen In Situ Resource Utilization Experiment technology. And the principle of its operation is separating oxygen atoms from carbon dioxide molecules. Fortunately, there's plenty of it on Mars, up to 96%. Is there a boundary that we, as humanity, will never cross? Are there places we will never reach, no matter how hard we try? There is, in fact. Even with incredible science fiction methods, we found ourselves trapped in a vast pocket of the universe and the matter within it. So how many universes are there really, and how far will humanity be able to venture into its depths? When we look at the night sky, it seems like we see stars being born and dying again in a cycle that appears endless, but that's how it is. Imagine the Milky Way with a diameter of up to 200,000 light years, containing from 90 to 450 billion stars. Answer the question, how many stars are born here in 1 year? Millions, thousands, but really just 3? Surprised? Only 3 stars a year. 96% of all the stars that have ever existed in the universe have already been born, and we are living in the twilight of the star formation era. Right now, we exist at the dawn of the end of the universe as we know it. Moreover, the formation of new stars will continue to slow down, but that's not all. As it turns out, the universe is running away from us. Also, the Milky Way is not alone. Together with Andromeda and more than 45 dwarf galaxies, they form the Local Group, a region about 9 million light years in diameter. You can think of this as our galactic neighborhood. From here, more than 100 galaxy groups like the Local Group make up the Laniakea supercluster, which itself is just one of a vast number of superclusters. In total, there are currently about more than 2 trillion galaxies that make up the universe as we see it at this point in time. Unfortunately, even if we were able to travel at the speed of light, about 93, the galaxies that we see at this moment can no longer be studied, which is why all these galaxies are already out of reach. This is due to how galaxies begin their existence with the Big Bang. Simply put, about 10 to the minus 36 seconds after the Big Bang, the young universe was a very small bubble of energy, but it wasn't completely uniform. Some parts were a bit denser than others, which had serious consequences in the future. In a process called cosmic inflation, the observable universe rapidly expanded from the size of a small ball to trillions of kilometers in a trillionth of a second. This happened so quickly that all those tiny differences in density were stretched from subatomic sizes to unimaginable galactic distances. And that's the only reason the visible universe consists of regions that are more and less dense, pockets of the universe filled with a bit more matter than the space surrounding them. Eventually, this brief yet powerful inflation ended as gravitational forces tried to unite everything. The local group is our home in the vast universe, but on a larger scale, beyond the compressed pockets, the expansion of space did not stop. This means that our local group is surrounded by matter, but none of these structures and galaxies are gravitationally bound to us. The more the universe expands, the greater the distances become between us and other centers of gravity. But what's even worse is that the universe is accelerating its expansion. So far, we don't understand why this is happening. That's why we come up with various hypotheses about the existence of dark energy. You can imagine it as some kind of invisible effect. It helps the acceleration of the expansion of the universe. So all we need to know right now is that the universe is expanding faster and faster. This expansion means that there is a cosmological horizon around us. Everything beyond its boundaries starts moving away from us at a speed faster than the speed of light. This leads to the conclusion that anything beyond the horizon is permanently inaccessible, and we likely will never interact with it. In a way, it's similar to the event horizon of a black hole. 93 galaxies that we observe today have already crossed it and are lost to us forever. But wait a second, if we have no way to interact with them, why are we still able to observe them? Well, for that, we can thank light. And although the speed of light is the fastest way we know to travel through the universe, it still requires traversing slices of time to cover the distance from one point to another. Every second, light reaches us from trillions of galaxies that have crossed the horizon, because when their light was emitted, they were closer to us. We study their past and understand their position at that time. In this way, the observable universe is literally larger than the universe we can interact with. In a way, the universe is writing an incredible story for us, showing us phenomena that are now forever out of our reach. We can only observe them over a long period of time as their light reaches our telescopes. The universe observed in real time is still expanding. It's truly breathtaking to realize this. All the centers of the universe beyond the local group will one day pass beyond our cosmological horizon. When that happens, their light won't reach us, and they'll vanish into darkness from our view. Every moment of your existence, 50,000 stars cross the horizon and disappear from us. Since you started watching this video, about 20 million stars have forever gone beyond our reach. I see. But if 93% of the visible universe is beyond the cosmic horizon and gone forever, there still should be 7% that should be within reach. For a moment, that's all the pockets of galaxies that are less than 19 billion light years away. At the moment, they're still moving away, but very slowly, so physically we can try to reach them, although the chances are dropping with every second. Anything that's more than 6 million light years away is running away from us, but the nearest groups of galaxies are moving away the slowest. That's why there's a temporary window to reach them even at the speed of light. The journey to the Maffei group and the nearest galaxy cluster outside the local group would take us 12 million years. Suppose some incredibly advanced civilization tries to do this. Its inevitable sphere of influence could expand to hundreds or thousands of galaxies. It can be confidently assumed that humans will not make this journey, at least not with technologies that are even remotely at the cutting edge of scientific thought. For humanity, the local group is the largest structure we will ever be a part of, because even traveling between the stars of this group would already be an achievement of colossal scale. As dark energy pushes the rest of the universe away from us, the local group will become more and more tightly bound together. All its galaxies, large and small, will merge together, forming a single giant elliptical galaxy with the non-trivial name Milky Andromeda or Milkomeda. This process may even disrupt huge gas clouds and temporarily restart star formation. And this single light will be highly desirable because at some point the galaxies beyond Milkomeda will be so far away that they will become too small to be seen. Once this happens, no information beyond the local group will be visible anymore. For us, the universe will disappear from visible observation. A being born in the distant future in Milkomeda will think that the universe consists only of its own galaxy. When they look far into the empty space, they will see only even more emptiness and darkness. They will not see the cosmic background radiation. They will not be able to learn about the Big Bang. Perhaps they will not have the opportunity to know what we know today, the nature of the expanding universe when it began and how it will end. They might think that the universe is static and has always been this way. Milkomeda will be an island in the darkness, growing ever blacker and darker, with its trillions of stars. The local group is certainly a large enough playground to entertain its inhabitants for some time. After all, we still don't fully understand how to leave our solar system. If not us, then our descendants still have tens of billions of years to explore our galaxy in more detail. And we're actually very lucky to exist in this ideal, perfect moment in time to see not only our future but also our most distant past, just by looking up at the night sky. Even if the local group is isolated, it's our home and humanity's final frontier. Maybe unlike science fiction dreams, we're limited to our immediate surroundings. And the Hubble channel will do everything it can to make sure as many people as possible learn about our cosmic homeland. It is well known that even the wildest ideas of science fiction writers and directors often appear in real life. Do you remember Miller's planet from the movie Interstellar, or Solaris from the book of the same name by Stanislav Lem? Both times it was about celestial bodies covered by a continuous ocean. Who hasn't heard of the desert Arrakis from Dune, or the legendary Tatooine from Star Wars? An example of a desert planet for those who are older is the waterless Pleiuk from Georgi Danelia's movie Kin Zadza. There's also Ego from Guardians of the Galaxy, Cybertron from Transformers, and Pandora from Avatar. All of them were once considered fantastic, absolutely unimaginable. That naive era is now in the past. Now telescopes are discovering similar, even more unusual celestial bodies, the description of which wouldn't have occurred to any screenwriter or writer. Today, let's try to dive into the dizzying world of exoplanets that inhabit the macrocosm. What are they like? Is there a limit to the universe's imagination? And what kinds of planets are we used to? Within the solar system, in addition to rocky objects with various conditions from our parent star, there are also gas giants like Jupiter and Saturn, as well as the frozen Neptune and Uranus. There was a time when astronomers short-sightedly believed that the solar system was something exclusive. But when telescopes began to actively explore the universe, it turned out that there are plenty of such celestial bodies out there. Hot Jupiters with extremely harsh conditions and literally boiling atmospheres orbit dozens, hundreds, and thousands of light years away from us. Worlds made of molten lava, super Earths of incredible size, Tatooines covered with tons of sand dunes, icy mini Neptunes, as well as restless outcasts, wandering celestial bodies. Have you noticed that even in the names of such objects, we use familiar names like Jupiter, Earth, or Neptune? But some planets stand out from the established groups with conditions familiar to us and remain apart because their parameters are hard to even imagine, let alone describe. So, here are the top 5 record-breaking exoplanets discovered by Earth-based telescopes. In total, more than 2,000 of these amazing objects have been found. The most wayward. Let's start perhaps with the wandering planet, Simp Joule, 13,656 5 plus 093347. At first, scientists mistakenly classified it as a brown dwarf, but then they took a closer look, studied it in more detail, learned the object's mass, which is about 13 Jupiter masses, and concluded that most likely it's a rogue planet. It has many names: quasi-planet, wanderer, orphan, floating planet, but the meaning of these names is the same. Such an object is not gravitationally bound to any star or system, like Sondage Infrarouge de Mouvement Propre, J013656.5 plus 093347. Either it orbits around the galactic core if it is in some galaxy, or it exists completely independently. As a hardcore feminist, you may wonder how a planet turned out like this. Most likely, it was ejected from a system due to a major cataclysm. Right now, the object we're talking about is in the constellation Pisces, about 20 light years from the Sun, but no one knows where it will be in a few centuries. The most luxurious. Are you attracted by the mysterious sparkle of diamonds? If so, then pay attention to the next object, Pulsar J1719-1438. B, a planet with a diamond core. It's located 4,000 light years from Earth. In the constellation Serpens, this is the only planet near a millisecond pulsar, or neutron star. According to indirect studies, the object is made of crystalline carbon. The conclusions are based on many parameters and systematically collected data. In particular, the high density of the celestial body, which is 23 times denser than water. It is believed the planet's atmosphere is mostly oxygen, while carbon lies deep within the planet under high pressure. By the way, near a much more distant pulsar, the universe's oldest planet was found, Methuselah or Piesarabisho. It is located in the constellation Scorpius, 12,400 light years from the Sun, and this ancient planet is about 12.7 billion years old. That means the planet appeared almost immediately after the Big Bang. The darkest. Can you imagine an object blacker than black? It's very difficult, but Earth-based telescopes managed to find such a planet. Its name is the gas giant TRES 2b, and it was discovered in 2006. The object is larger than Jupiter, and its atmospheric temperature is about plus 980 degrees Celsius. So compared to this hell, the stifling Venus would seem like a cool ski resort, although to be fair, there is an even more hellish place. This is the planet Kelt 9b, where the surface temperature is plus 4,315 degrees, which is almost like the Sun. It is 650 light years away and 3 times larger than Jupiter. Now let's return to our ranking participant. Scientists were surprised not by the surface temperature, but by how the object is darker than coal, soot, or any planet. Before this, it was observed that almost all the light that hits its surface is completely absorbed. One can only imagine how terrifying it must look from the outside. The most spectacular thing is, how many suns are there on Earth's horizon? Any schoolchild knows the answer to this question. But 1,800 light years from Earth, there is a planet with the code name CO5AB, which has 3 parent stars. A triple system is a relatively rare phenomenon, but just imagine what sunsets look like on the surface of this mysterious planet. The object is located in the constellation Cygnus and was discovered, like many distant exoplanets, by the transit method. This means it was found by the slight change in the brightness of its parent star when the planet passed in front of it. By the way, this doesn't happen rarely, but actually once every 5 days. That's how short a year is on CO5AB. Conditions in triple star systems are quite unstable for the steady and productive development of planets, so this object is a rather harsh place. It is assumed to be a completely frozen gas giant, similar to our Neptune. The most exotic thing, how do you imagine ice? Cold, hard, brittle? Forget it, those are all earthly preconceptions. On Gliese 436b, the ice is completely different. It's literally burning. At least that's what scientists claim. This planet is only 33 light years away from Earth. It is believed that a huge amount of water is hidden beneath its surface. And since this liquid is compressed under a titanic atmosphere, while from below this impressive layer is heated by a scorching core, such unusual conditions have resulted in a substance unfamiliar to us: hot ice. The mentioned object is not the only one in this region. Its neighbor, Gliese 504b, which is also known as 59 Virginis b, was discovered by the Subaru telescope at the Mauna Kea Observatory. It is a huge gas giant that is much farther from radiation, and this completely overturns theories about the formation of giant planets near stars. The surface temperature of 59 Virginis b is about 280 degrees Celsius, which is incredibly hot. Astronomers still debate whether it's a planet or a brown dwarf. The thing is, in 2015, more accurate measurements of Gliese 504b's mass were obtained, and it is about 30 times the mass of Jupiter. So, which planet have we saved for dessert? This is a bonus from the Hubble channel, and we didn't even include it in the top list. Meet the ocean planet Gliese Yaris 1214b. It's 3 times bigger than Earth, located 42 light years away from us, and is completely covered in water. The mass of the ocean makes up more than 10% of the planet's total mass. To make this enormous number clearer, let's compare it to Earth. All the water on our planet makes up just 0.05% of its mass. The oceans on Gliese Yaris 1214b can reach depths of up to 1,600 kilometers. Of course, this is by no means the full list of exoplanets. We can mention Henry Draper 18,973b with winds reaching speeds of up to 9,000 kilometers per hour and rains of scorching hot snow, or Core 7b, with stone clouds that occasionally shower the planet with hot snow made of boulders, as well as many other incredible celestial bodies. But we'll still wait for further research because we believe the inhabitants of planet Earth are in for some surprises. Go to the comments and share your guesses about what other exoplanets will be discovered in the near future.